Hello students, today I am going to explain you about zero error in screw gauge. What is the meaning of zero error in screw gauge? As you can see here, it is the zero error. It is the screw gauge. How will you know that whether it is having a zero error or not? So what is the procedure of that? Here also, like the vernier calipers, you will bring both the gauge in contact. You will bring both the gauge in contact. If on bringing both the gauge in contact, zero of the circular scale means this. This is the zero of the circular scale that you can see. Here this is the zero of circular scale. It is marked here also. Zero of circular scale. If it is along the baseline, you can see here, this is the zero of circular scale and it is along the baseline on the sleeve. What is sleeve? Sleeve is this part. This cylindrical part which is attached with the nut. This one is the sleeve. It is clear? On which these 15 divisions are marked, this is sleeve. So, if on bringing both the gauge together in contact, zero of the circular scale is in line with the baseline. It is clear? Then it means there is no zero error. But if you see here it is not so. Here, when you join it completely, now it is completely joined, you can find that zero is not along the baseline. Zero line is not along the baseline. Some other division is coinciding to the baseline. Zero is not coinciding. Zero is above to the baseline. You can see here. Baseline is this. Is it visible? This is the baseline. This is baseline and zero is here. This is the zero. It is above to the baseline. It means this screw gauge is having some zero error. Similarly, it is also possible that on bringing both the gauge together in contact, zero is below to the baseline. In this case also there is zero error. It means how will you know whether there is zero error or not? You bring both the gauge in contact together. You bring stud and tip of the screw in contact. If zero of circular scale is in line to the baseline, is in straight to the baseline, then it means there is no zero error. But if it is not so, then there will be some zero error. This I am showing in the diagram which is given in your book. You can see here. You see this diagram. Yes. Here, if you join both the gauge together, what has happened? Zero is lying below to the baseline. It is clear? Zero is lying below to the baseline. There is another diagram. Here you can see. If you join, then you will find that zero is, I am bringing the camera near to it, zero is above to the baseline. It means in both the cases there is zero error. Now what is positive zero error and what is negative zero error? Positive zero error when the zero of the, if on joining stud and screw in contact, if zero of circular scale lies below to the baseline, then there is positive zero error. And if on joining stud and screw in contact, if zero of circular scale lies above to the baseline, then there is negative zero error. How will you calculate this positive and negative zero error? So first we see about the positive zero error. You can see here in the positive zero error, first you find the coinciding division. So which division is coinciding here? So you can see here in this diagram, fifth division is coinciding. So what will be the positive zero error? So positive zero error formula is, you can see, positive zero error, it is coinciding division into least count. It's clear? With plus sign. Here least count the screw gauge which we are using or which this is given in the book, whose diagram is printed in the book, its least count is 0.01 mm. In the last lecture I have told how will you determine the least count of screw gauge. It is pitch upon number of circular scale division. Pitch means it is the distance moved by the tip of the screw on given one full rotation. It is clear? On given one full rotation. It is the distance between two consecutive threads of the screw. So positive zero error in this case will be what? 5 into 0.01 mm, that is plus 0.05 mm. As already I have told, in the vernier calipers, if there is positive zero error in any instrument, then the observed value, that is the measured value, will be more than the actual value. So how will you obtain the correct reading or correct length or correct diameter? It will be the observed reading minus zero error with sign. So positive zero error gets subtracted. Now similarly in the negative zero error, how will you find? So if you see the negative zero error in this diagram, if you see which division is coinciding, 95 division is coinciding. When stud and tip of the screw are brought in contact, then 0 lies above to the baseline, therefore there is negative zero error, and coinciding division is 95. So how will you calculate the negative zero error? So see here, negative zero error formula is within bracket total number of divisions on circular scale minus coinciding division. Bracket close into least count and then minus sign before that. So here there are how many divisions on circular scale? 100. 100 minus 95, that is 5. 5 into least count, that is minus 0.05 mm. When you will subtract it, as you know that correct reading is observed reading minus zero error with sign. When this zero error will be subtracted, minus and minus will become plus, means it will get added. It will get added. So this is about the zero error in the vernier in the screw gauge. This I have told. Now see here, there is one backless error. What is the backless error meaning? It's clear. What is backless error? So when we are using this, then the threads of the screw are damaged, will get damaged. It's clear. Due to the wear and tear, what will happen? Threads of the screw will damage. So what will happen? Suppose you are rotating in one direction. If you are rotating in one direction, tip will move forward. But if suddenly you start moving in the reverse direction, you are rotating in one direction, tip will move forward. It's clear, tip will move forward. But if you suddenly start rotating in the reverse direction to the circular scale, to the ratchet, what will happen? The screw will rotate at its own place, means the tip will not move back. Screw, because of the wear and tear, it will be rotated at its own place, but the tip of the screw will not move. It's clear, it will not move back. This type of error is known as the backless error, and it can be avoided. How you can avoid it? So suppose if you are rotating in one direction and then you want to rotate in opposite direction, what will you do? You wait for few seconds and then rotate in the reverse direction. So this way we can avoid the backless error if there is any. It's clear? If there is any backless error, then that can be avoided. So this is all about the screw gauge. It's clear, and zero error of the screw gauge. Thank you.